Assalamualaikum and good day. We are from Group 5. We'll present a group assignment regarding memory access. Our group members are Muhammad Ashraf Hakim bin Muhammad Zaki, Muhammad Hadi Syazzul bin Muhammad Hafiz, Muhammad Syazzul bin Cik Aziz, Solihah binti Rahmat, and me, Siti Nur Asyiqin binti Muhammad. For our problem statement, the assignment focus on managing data transmission within a computer system, specifically using assembly language to store and relocate capital letters in the English alphabet. The letters are initially placed at random position in program memory and need to be transferred to contiguous block of SRAM to enable specific processing procedure. The process involves reading and writing the letters into assigned SRAM address. Writing an assembly program to efficiently move this data is challenging, and it must find, extract, and store the capital letters in the designated SRAM address range. Understanding memory address, data transfer instruction, and efficient assembly language looping process is required.
Hi and Assalamualaikum. My name is Muhammad Syazzul bin Aziz. We will explore how to assembly language, programming and direct memory access (DMA) can improve efficiency in data transfer task solution that I have to. So this is my part. So for the introduction, embedded system using data transfer between program memory, which is SRAM memory, is crucial for performance. Traditional method may be inefficient, leading to CPU overhead and slower execution. For the assembly language, so here we can know that assembly language programming is utilized assembly language programming to directly memory operation and data movement, and it provide fine-grained control over source. And then for the assembly language allow for direct control over hardware resources. We write efficient assembly routine that initialize data in program memory between memory location. For the DMA, which is direct memory access, implement DMA controller is available in the controller to offload data transfer task from the CPU. So DMA controller upload data transfer task from CPU. This frees up CPU resources for other tasks and improve overall system and our performance. Then problem solving or strategy, technique, language and step tool. So the choice assembly language depend on the processor architecture. Common choice include x86 assembly for Intel and AMD processor, and then ARM assembly for ARM processor, and MIPS assembly for MIPS processor. Strategy and technique. One common strategy of programming assembly language is to break down the problem into smaller, manageable parts. In this case, we want to write assembly code to save the data in the program memory and copy the memory block into SRAM memory. And then for language, assembly language is a low-level programming language mostly tied to a specific CPU architecture. That is the assembly language you use depend on the architecture. Common assembly language including 89 assembly for Intel and AMD processor. Common choice is Intel, AMD processor and ARM for ARM processor. So for CAD tool, we use Keil version as our main CAD tool, which provide an integrated development environment IDE with tools such as chamber, debugger, simulation, and linker, facilitating the development and testing of assembly code for embedded system. So we choose CAD tool for our to use Keil version. And then for conclusion, which is our approach ensure the efficient utilization of hardware resources and timely deliver of a solid solution by optimize data transfer using assembly language programming and DMA. We can improve the performance of embedded system and meet project objective efficiently.
This is flowchart part. Based on this diagram, got 7 part on the flowchart. For the number 1 is start or end, which represent the beginning and end of the process. Number 2, define data. In this step, data is defined or initialized. For example, an array named data_array could be defined to hold the data to be processed. Number 3, store data in program memory. This step involves storing the defined data in program memory. It could include actions such as initializing variables, arrays, or other data structures. Number 4, Read data from program memory. Data previously stored in program memory is read or accessed for further processing. This step ensures that the data is available for manipulation. Number 5. Move data to SRAM, from memory address 0x10000 to FFF. This step entails transferring data from program memory to SRAM, starting from the specified memory address 0x10000 to FFF. It typically involves copying data elements one by one from program memory to SRAM. Number 6. Check if data transfer to SRAM is successful. After moving the data to SRAM, this step verifies whether the data transfer operation was successful. It could involve checking if the data in SRAM matches the expected data from program memory. Number 7. End processing. This final step marks the conclusion of the process. It signifies that all required operations, including data storage, retrieval, and transfer, have been completed. The program terminates at this point.
My name is Syazzul the coding for the assignment. Suppose that all 26 uppercase letters of English alphabet are stored at any location in the program memory. So what we need to do is to transfer this data. Using this, I can choose any, but I will choose by using this memory. So for the R1 is 1 million, and for the R0 is 1000 to FFE, and for the R3 00000 and 41. So it is the content that we need to store inside the address. So store by byte, add, and then compare. EQ done, and then we do this to run into reboot, and then debugs. After debug, you can see in this memory request investigated for assignment said that need to transfer from program memory to SRAM. So this is the sequence that we need to do. First, select this, and then start. And then if you can see the memory this and memory 1, so you can step by step. Okay, you can see store for 1, that's me, like this for 1, and then you can see inside here is for 1, 2. So starting from this to FFE. So now the data for 41 is now stored at this and this address, and then transferred to this address, as I said, from memory this to this. So we will continue until what you want. So you want until 5A. So we proceed with 5A. You can see the memory view until it store 5A. So now for A, for B, for C, for D, for E, for F, for 1, 2, 3, 54, 55, 56, 57, 58, and then 59. Lastly 5A. So you can see now this is the last one. So it's now has been completed. So there is no other thing to execute. To store this 41 to SRAM, from program memory to SRAM. So now it's stopped and at 50 at 5A. So 5A means that the Z. How we know that is the Z? It is from the SC table. You can see the starting alphabet is 41. So then it will be saved 5A. So 5A is Z, the last letter. So it will save from 41 or A until Z by using the alphabet, and using the RC table by using the hexa number. So by this coding, this load direction, load register R1, load register R0, load register R3.
I will show you the result after running the coding. So this is the result we obtained from the running the codes. Memory 1 is represent program memory, while memory 2 is represent the SRAM. So the data being transferred originate from program memory at starting 0 times 1 0 0 0 is 0. It moved to SRAM memory starting at address 0 times 100 to FFE. So the address at 0 times 100 is 0. The data value is 41, which moved to address here to FFE in SRAM. So subsequently, data at address 81 is here. For the data is 42. We'll move to address to next address, which is here. So lastly, the data for FA in here, which is address 0 times 10099, will move at here at location address 3017. So what we can see, the coding and the result is same like instruction given in figure 1.